in the last lecture, we have started with the method of partial fraction and we have solved two problems. Okay. So, in this lecture, we will see some more problem based on that. So, let us have some more problem based on the method of partial fraction. Okay. So, here we have to start with the method of partial fractions. So, we have solved two problems. We'll try to solve more. Okay. So, let's have the example. Okay. Find inverse Laplace transform of the power of s is equal to 2s s square plus 2s plus 3 upon s square plus 2s plus 2 and s square plus 2s plus 5. Okay. So, this is the example. Okay. I hope we have not done this example earlier. Okay. Good. Okay. So, let what is f bar of s given to you? S square plus 2s plus 3 upon we have s square plus 2s plus 2 and here we have s square plus 2s plus 5. Okay, so here clearly we have this equation 1. Okay, so clearly we have two quadratic factors. This is a quadratic factor, this is a quadratic factor. We cannot factorize this in reals and hence we go for partial fraction. So we have, what is the term you will be having here? S square plus 2s plus 3 upon s square plus 2s plus 2 s square plus 2s plus 5. Please be careful while writing s and 5. So here, being this is a quadratic factor, I have to consider the numerator as as plus b. Okay, and this is the first factor that we have, s square plus 2s plus 2 plus we'll be having cs plus d. Okay, so I'll be having here s square plus 2s plus 5. Now we have to simplify this, so we'll get s square plus 2s plus 3 is equal to, use proper brackets please, as plus b into s square plus 2s plus 5 plus cs plus d into s square plus 2s plus 2. Okay. So we'll have here this simplify these terms. So I'll be having s square as cube. Okay. Then bs square plus 2as square plus 2bs plus 5as and plus 5b. So this is the product of these two brackets. Now this bracket plus cs cube plus ds square plus 2cs square plus 2ds plus 2cs plus 2d. Okay, this is what the product of this next two brackets. Now, what we'll do is we'll collect the terms with similar power of s. So I'll be having a plus c into s cube. This is going to be s square plus 2s plus 3, then plus. So square terms we have 2a plus b plus 2c plus d and s square. Now for s we have 5a plus 2b plus 2c plus 2d and the constant terms. So it is 5b plus 2d. So we have collected all the terms. This is for s. So we collected s cube, we collected s square, then we collected s, and then we collected constant terms. Now comparing coefficients of s cube, s square, s, and constant terms on both sides, we get. So what we are able to get is, see, there is no term of s cube. So this a plus c is equal to 0. Now think of this term. So we have 2a plus b plus 2c plus d is equal to, the coefficient of a square is here 1. So this is going to be 1. Now, yes, so we can have 5a plus 2b plus 2c plus 2d is equal to, the coefficient of s is 2 here, so this is 2. And then the constant term on both sides, so 5b plus 2d is going to be 3. So I have 5b plus 2d is equal to, okay. So now we can say a plus c is equal to 0. That means a is equal to minus c, or c is equal to minus e. So from this equation, what I can do is I can write this as, I can rewrite this equation as twice a plus c plus b plus d equal to 1. And what we know is a plus c is equal to 0. So that means that this term is going to be 0. So this term is 0, and hence I am able to write. So I'll write here b plus d is equal to 1. So this is going to be 1 because this term is going to be 0. Now we can simplify this. Okay, so it is 5a plus 2c plus twice b plus d is equal to 2. Now we know b plus d is going to be 1. Okay, and hence I can replace this term b plus d. So it will be 5a plus 2c plus 2 into 1 is equal to 2. And hence I'll have 5a plus 2c. This is going to be 0. Because this 2 I'll have, this 2 will get cancelled. So we have, so actually if we look at the first equations, what we'll get, we feel that it is the 4 by 4 system of linear equations which we cannot solve by using calculator. But if we use this equation, then it reduces to two systems of 2 by 2. So what are the two systems of 2 by 2? A plus C is equal to 0. 5A plus 2C is equal to 0. And we get B plus D is equal to 1 and 5B plus 2D is equal to 3. Okay. So this way, this equation reduces to the smaller system of linear equation. This is a 2 by 2 system. This is a 2 by 2 system, which we can solve easily. So right here, solving above systems of linear equations, we get. Okay, so what we are able to get is calculate this values and tell me what you will get. So please calculate this values and tell me what you will get. So I get A is equal to 0, C is equal to 0, B is 1 by 3 and D is 2 by 3. Okay, that's good. Okay, so we got these values and now we can use these values here in equation 1 and we can simplify this function f bar of s. So let us see what we'll get f bar of s. So then we have f bar of s is equal to, so I'll be having 1 by 3 s square plus 2s plus 2 plus 2 by 3 s square plus 2s plus 5. Okay, because a is equal to 0, so as plus b, and this was cs plus d. So a is equal to 0, c is equal to 0. So I'll be having b and d here. And moreover, we can have this 1 by 3 common. So I'll be having 1 upon s square plus 2s plus 2 plus you'll be having 2 upon s square plus 2s plus 5. Okay, so this is what you have. Okay, now we have to simplify this. So this s terms gives us the idea that there is going to be a shifting property, first shifting property. So we have to express these terms s square plus a square, also this term s square plus a square. So how we are able to express these terms as s square plus a square? So we can have, okay, this is s square plus 2s plus 2. So we can write this as s square plus 2s plus 1 plus 1. And you can see this is a perfect square. So you have s plus 1 bracket square plus 1. Now for this term s square plus 2s plus 5. So this is s square plus 2s plus 1 plus 4. And you can have, again, this is a perfect square. So s plus 1 square plus 4. So this you are able to express as uh, s plus 1 s square plus a square. This is also s square plus a square. And now we are able to simplify it here. So it is going to be 1 by 3. You have 1 upon s plus 1 bracket square plus 1 plus this is 2 upon s plus 1 bracket square plus. Okay. Now this is going to be bar of s, and hence this is in the simplest form. So we can have the inverse Laplace transform of this. So now we consider inverse Laplace transform of a bar of s. So it is inverse Laplace transform of 1 by 3, and here you have 1 upon s plus 1 bracket square plus 1 plus 2 upon s plus 1 bracket square plus 4 Please use proper brackets, okay, so that you will not miss any term. This is equal to this 1 by 3 being constant. We can use the linearity property of Laplace transform. So we have s plus 1 bracket square plus 1, and this is plus Laplace inverse of 2 upon s plus 1 bracket square plus 4. Okay, so that's what we'll be having. Now we have the property. This is going to be e raised to minus the Laplace inverse of 1 upon s square plus 1 plus this 2 I can have outside, e raised to minus t Laplace inverse of 1 upon s square plus 4, and that's what it is. This is equal to e raised to minus t is common, so I can write this e raised to minus t by 3. Now the Laplace inverse of this is going to be sine t plus 2 into Laplace inverse of this is again going to be sine of 2t by 2. Okay, so this is what we are able to get. This is equal to what I'll be having, e raised to minus t by 3, and here I have this is sine t. This 2 will get cancelled, plus sine of 2t. So we get here inverse Laplace transform of a bar of s is equal to e raised to minus t by 3 sine t plus sine of 2t. Okay, so that's what we are able to the example. Can have find the inverse Laplace transform of the bar of s is equal to 3s minus 2 upon s minus 3 s square plus 2s plus 2. Okay, so we go with the solution. Okay, so what we have here, uh, this we have one linear factor and one quadratic factor, and moreover, this quadratic factor is the irreducible quadratic factor. Okay, so let this equation 1. Okay, now we have es minus 2 upon s minus 3 s square plus 2s plus 2, and this is equal to a for the linear factor plus ps plus c for this quadratic factor. So s square plus 2s plus 2. Now we have this is 3s minus 2 is equal to a s square plus 2s plus 2 plus bs plus c into s minus 3. So simplify this, we have a s square plus 2as plus 2a plus bs square plus cs minus 3bs and minus 3c. Now collect these terms. So you will have a plus b s square. We collect the term with the same power of s. So plus 2a, then we have minus 3b plus c s, and then constant terms. So we'll be having plus 2a minus 3c. So it is 3s minus 2. Okay, so we have got the terms of s square, we have got the terms of s, and then we have got the constant terms. Okay, now what we have here, we'll compare the coefficients. See, one thing is important, this comparing coefficient methods gives you always the correct answer. Okay, so please adapt to this instead of putting, if you have all linear factors, then you can put the value of the term, and then yes, and then you can get the value of constant. So here what we'll do is we'll comparing the coefficients of s square s and constant terms in constant terms on both sides. We get a plus b. So we don't have any term of a square here. So we get a plus b is equal to 0. Then we have 2a minus bb plus c is equal to 3. And then we have 2a minus 3c is equal to minus 2. So what we can write is solving above system of linear equations. Above system of linear equations for A, B, and C. Okay, we get. So I want you to calculate A, B, and C. Okay, so here we got the value A is equal to 7 by 17. This is minus 7 by 17, and this is 16 by 7. Okay, so we are able to get these values, and once you get these values, we are able to write the expression 1. Okay, so what we have given function. So given function is a bar of s. So I can write a, b, and c. So let us write this a, b, and c. Okay, so we have f bar of s is equal to 7 by 17 upon s minus 3 plus this is minus 7 by 17 s plus 16 by 17 s upon s square plus 2s plus 2. Okay, so we can see that 1 by 17 is common. So I can take this 1 by 17 common, and I'll have this is 7 upon s minus 3. Then this will I'll write as minus 7s minus 16 upon s square plus 2s plus 2. Okay, now here we know there is a shifting property, first shifting property. So we have to express the numerator as the denominator. Okay, or in terms of whatever the shifting property we have. So first we have to find out what shifting property we have. Okay, so let us simplify what is in the denominator we have. So it is s square plus 2s plus 2, and this is s square plus 2s plus 1 plus 1. So it is s plus 1 bracket square plus 1. So in the denominator, we have the term s plus 1. So we have to get it into the numerator. And hence this 7s minus 16, we have to express as in terms of s plus 1. So I'll write here a s plus 1 plus b. So we have already used capital constant. So I'm using the small constants here. So this I can write as as plus a plus b. So it is going to be 7s minus 16 as plus a plus b. Okay, and now we can compare the coefficient on both sides. So I get a is equal to 7. Okay, so once I get a is equal to 7, then I get a plus b is equal to minus 16. Okay, so if I simplify this, what I'll have is I'll have b is equal to minus 16 minus 7. So it will be minus 23. So b is going to be minus 20. Okay, so we got the value of a, we got the value of b, and so we are able to write down this term. Okay, and hence we have this is 1 by 17, 7 upon s minus 3 minus, in the numerator we have this is 7 times s plus 1 minus 23. In the denominator we have s plus 1 bracket square plus 1. Okay, so that's what we have. Now this is the simplest form of f bar of s. So we are able to find the inverse Laplace transform now. Okay, and hence we get inverse Laplace transform of f bar of s is equal to inverse Laplace transform of 1 by 17 we'll have here this is going to be 1 by 17, and here this is 7 upon s minus 3 minus 7 s plus 1 minus 23 upon s plus 1 square plus 1. That's what you're getting. So as I said, please use proper bracket. So 1 by 17. Now using the linearity property, we can have this is 7 upon s minus 3 minus Laplace inverse of 7 s plus 1 minus 23 upon s plus 1 bracket square plus 1. Okay, and this is equal to what is the term we are able to get here. So we have this is 1 by 17, 7 times Laplace inverse of 1 upon s minus 3 minus e raised to minus t Laplace inverse of 7s minus 23 upon s square plus 1. Okay, and this is equal to 1 by 17, 7. Here we'll be having Laplace inverse of 1 upon s minus 3 minus e raised to minus t. Again, we have to use the linearity property here. So minus t is common for both this. So Laplace inverse of 7s upon s square plus 1 minus minus plus e raised to minus t. Laplace inverse of 23 upon s square plus 1. That's what you'll be having. Okay, and now simplify this. So we have this is 1 by 70, 7 times e raised to 3t minus this 7 you can take outside and you'll be having e raised to minus t. This is going to be cos of t plus 23 e raised to minus t, and this is going to be sine of t. So we got here as inverse Laplace transform. Okay, so this is inverse Laplace transform of we got inverse Laplace transform of a bar of s is equal to 1 by 17. This is what we'll be having 7 times e raised to 3t minus 7 times e raised to minus t cos t, and this is plus 23 times e raised to minus t. Okay, so this is how we are able to get the inverse Laplace transform. Now we'll see next example. We can have find find inverse Laplace transform of 5s minus 7 upon s minus 1 s plus 2 bracket square. Again, so we go with the solution. Let f bar of s is equal to 5s minus 7 upon s minus 1 s plus 2 bracket square. So here this is going to be equation 1. Now we consider the partial fraction. So we have 5s minus 7 upon s minus 1 s plus 2 bracket square. This is equal to a upon s minus 1 plus b upon s plus 2 plus c upon s plus 2 bracket square. So this is 5s minus 7 is equal to a into s plus 2 bracket square plus b into s minus 1 s plus 2 and plus c is c into s minus 1. Okay, so that's what it is. Now here you can have you can put the value of s is equal to 1 and s is equal to minus 2 and get the value of p, or you can use the coefficient method. So we can have a into this is s square plus 4s plus 4 plus this is b into s square minus s plus 2s minus 2, and this is c into s minus 1. So it is a s square plus 4as plus 4a plus bs square. This term will be plus bs minus 2b plus cs minus c. Okay, so collecting the coefficients, we are able to get this is a plus b s square plus 4a, then plus b plus cs and constant 4a minus 2b minus c. So it is 5s minus 7. Okay, now we can compare the coefficient on both sides. So we have comparing the coefficients on both sides we get. So we have a plus b is equal to 0 as we don't have the value, we don't have the term of a square here. Then this is 4a plus b plus c is equal to 5, the coefficient of s, and 4a minus 2b minus 2b minus c is equal to minus 7. Okay, so that's what the equations we have. So we can solve this equation. So solving above system of linear equations, we get. So what we are able to get is a is equal to b is equal to and c is equal. It's going to be minus 2 by 9. This is going to be 2 by 9, and this is 17 by 3. Okay, that's what the values we have got. Correct. So once you have these values, now we put these values in equation 1. Okay, so what we have equation 1, then we have the bar of s is equal to. So here this is going to be minus 2 by 9 upon s minus 1 plus 2 by 9 upon s plus 2 and plus 17 by 3 upon s plus 2 bracket square. Or we can write this as a bar of s is equal to minus 2 by 9 1 upon s minus 1 plus 2 by 9 1 upon s plus 2 plus 17 by 3 1 upon s plus 2 bracket square. So now we are able to take the inverse Laplace transform of this, and hence we have inverse Laplace transform of a bar of s is equal to inverse Laplace transform of minus 2 by 9 1 upon s minus 1 plus 2 by 9 1 upon s plus 2 plus 17 by 3 1 upon s plus 2 bracket square. So here we have, by using the linearity property, minus 2 by 9 Laplace inverse of 1 upon s minus 1 plus 2 by 9 Laplace inverse of 1 upon s plus 2 plus 17 by 3 and Laplace inverse of 1 upon s plus 2 bracket square. Okay, so now we are able to get this as this is going to be okay, this is going to be minus 2 by 9 e raised to t plus 2 by 9 e raised to minus 2t plus 17 by 3 for shifting property e raised to minus 2t Laplace inverse of 1 upon s square. This is minus 2 by 9 e raised to t plus 2 by 9 e raised to minus 2t plus 17 by 3 e raised to minus 2t, and the inverse of this is going to be t. So this way we are able to get the inverse Laplace transform of a bar of s. So we got inverse Laplace transform of a bar of s is equal to minus 2 by 9 e raised to t plus 2 by 9 e raised to minus 2t plus 17 by 3 e raised to minus 2t into t. So this is what we are able to